This is your lesson on rational expressions, functions, and asymptotes. You will find the domain of rational functions, find horizontal and vertical asymptotes of graphs of rational functions. A rational function is a quotient of two polynomials. For example, this is a rational function because it's a quotient. That means it looks like a fraction with x in the numerator and in the denominator. The general formula for this is we use n as the function of the numerator and d as the function of the denominator. Okay, so for this graph, we're going to find all of these following bits of information. Here we go with the domain again. The domain, remember, is what's on the x-axis. So if this graph was on the x-axis, it would look like that. Everything on the x-axis, right? If you soaked it all up, it would just pass through the zero, skip over the zero. So the domain would be from negative infinity to 0, jump over the 0, and then go from 0 on to positive infinity. What about the range? The range is what will fit on the y-axis. And for this particular graph, it would be this, where we have, it will go from negative infinity all the way up to 0, jump over the 0, and keep on going. That's where the graph would be on the y-axis. Intercepts. Where are the x and y intercepts of this graph? Well, since these x and y axes are never going to touch my graph, we have no intercepts. Decreasing, increasing. Just remember that when we're talking about decreasing and increasing, we're always talking about the domain only. The domain is what's on the x-axis. You remember what we got for the domain from negative infinity to 0, jumps over the 0 to positive infinity. Now going in that direction from left to right, like if you're traveling on this road, this x-axis was a road from the west coast to the east coast. Okay, you never go from right to left, always from left to right, like the way you read. Going from left to right, you're in a car on the road, which is x-axis. You're looking at the scenery, and let's say the graph is a mountain or a hill. You're looking at the scenery, you go, oh look, the function is going down, it's going down, it's going down, it's going down, and then it does nothing here at 0. But on the other side of 0, it's still going down. It's still going down as you're going from left to right. You see that the function is going down. So it's decreasing from negative infinity to 0 and from 0 to positive infinity. Where is the domain increasing? So if you're still in this car, right, going from left to right, well, you just said it went down everywhere except for 0, so where is it increasing? It's not increasing anywhere because at nowhere is it going up, okay, from left to right. Vertical asymptote. A vertical asymptote is a line, equation of a line, where the graph comes close to but will never touch. So there's a vertical asymptote, so it's at x is equal to 0. What about horizontal asymptote? I see one at y is equal to 0, because that's a line that the graph keeps coming towards but it can never touch or cross. Okay. All right, let's try some examples here. For this function, I've graphed it for you and want to know the domain. And the domain, as you can see, is from negative infinity, traveling on the x-axis, and it goes to negative 1, then it jumps over the negative 1, and then it continues on going on the bottom half of the graph. So we can say that the domain goes from negative infinity to negative 1, jumps over the negative 1, and continues on to positive infinity. What about the horizontal asymptote? Do you see a horizontal asymptote? Yeah, there's one right there. And that's because the both sides of the graph tries and gets close to that line, but will never cross it at y is equal to 2. What about the vertical asymptote? I see a vertical asymptote there, okay, at 1, at negative 1, so x is equal to negative 1. You can see that the vertical asymptotes will cut your domain into sections. In this case, there's one cut, so there will be two pieces. If we had two vertical asymptotes, it would cut my domain into 3 pieces. Let's do another one. Number 2, what is the domain? The domain is from negative infinity all the way to positive infinity because it's continuous on both sides. If you put the blue line onto the x-axis, you will see that it goes from negative infinity to positive infinity. Asymptotes, there's an asymptote right there on the x-axis, so y is equal to 0 is the horizontal asymptote. Vertical asymptote, there is no vertical asymptote. Number 3, what is the domain? It goes from negative infinity, it goes all the way up to 1, goes past the 1 because now the graph goes to infinity. It has to jump from positive infinity on one side to positive infinity on the other side, and it will continue on. So the domain is from negative infinity to 1, and then it goes from 1 to infinity. And the horizontal asymptote is at the x-axis, so y is equal to 0. And the vertical asymptote is at x is equal to 1. And remember that the vertical asymptote is where we cut the domain up into pieces. Let's try another example here. Number 4, f of x is 1 over x. So the domain will be from negative infinity. See if you can figure this one out. It's going to have to jump over the 0 and continue going. So that will be from negative infinity to 0, from 0 to positive infinity. And the horizontal asymptote will be at y is equal to 0, the x-axis. And then the vertical asymptote will be the y-axis, or x is equal to 0. There's another one. How about this? We have the domain is from negative infinity all the way to positive infinity. There's no breakup in there anywhere. So that's the domain. And the horizontal asymptote. Now this is kind of a special case here where you can see that the graph actually crosses the asymptote. But if you look at the ends, it is an asymptote because this graph keeps trying to get closer and closer to this line, and it will never cross it. Okay, but it can cross it at one place if it just goes straight through it. But the asymptote is a line where the graph keeps trying to get close to, but doesn't touch it, and that happens on both ends of this. So yeah, y is equal to 0 is a horizontal asymptote. Vertical asymptote, there aren't any because there is no place where this graph is trying to get close to vertically. What do you think the domain of is for this? Okay, now the graph is in 3 pieces. So from negative infinity, now it's going to go all the way up to positive infinity, right? The y is going to go to positive infinity. Then it starts over at negative infinity for the second part of this graph, from negative 1 to positive 1. Then it jumps back to positive infinity, and it keeps on going. So the domain has 3 parts. Okay, it goes from negative infinity to 1, jumps over the negative 1, continues on to positive 1, jumps over the positive 1, and continues on to infinity. So that tells you that there should be, I was talking about the vertical, but the horizontal asymptote, there should be one right there at y is equal to 2. I don't know why that says 1. That's a typo. That should be a 2. And then there are 2 vertical asymptotes at x is equal to negative 1 and positive 1. So you're going to have to ignore this here. I thought I changed this. I don't know why it didn't change here. That's a 2. This is a 1 and a negative 1. My two vertical asymptotes. Okay, let's hurry this one along. I think you get the idea. You have the domain is negative infinity to 3, from 3 to positive infinity. Horizontal asymptote at 1. Vertical asymptote is at 3 because the 3 will cut your domain into 2 pieces. Alright, this one's kind of unusual, but the domain is from negative infinity to positive infinity, and then you get a horizontal asymptote at negative 1 and another one at positive 1. Okay, let's talk about the asymptotes. You have this form here where you have some kind of polynomial, and we're talking about the leading term, the one with the highest exponent, and then we're just going to ignore these when we're trying to find the asymptotes. Okay, for the vertical asymptote, you make the denominator equal 0. We can't divide by 0, so those are the places where we're going to have undefined places on the graph. Horizontal asymptotes, if the exponent on the numerator is smaller than the exponent on the denominator, then the asymptote is at y is equal to 0. In other words, if the numerator has a bigger, smaller exponent than the denominator, then there will be no, and I remember this by saying BOBO, bigger on the bottom. Bigger on the bottom, and then I get a 0 because y is equal to 0. So bigger on the bottom and y is equal to 0. That's where that's a 0. Bigger on the bottom, that's a 0. And if they're equal, then you're going to have to take y is equal to a over b. If you can think about it this way, if the exponents are the same, these kind of cancel, because there's some other stuff going on, but they kind of cancel, and then you're left with 6 over 3, and that's going to be your horizontal asymptote if the exponents are the same. So 6 over 3 reduces to 2, so you have a horizontal asymptote at y is equal to 2 when the exponents look like this and they can cancel each other out. Now the last case is when it's bigger on the top, when the exponent's bigger on the numerator, then there aren't going to be any. Okay? So if the exponent in the numerator is bigger than the exponent in the denominator, then there is going to be none. Bigger on the top, then there will be none. Alright. So what about this? We have find the asymptotes of the function. Which one is this? Is this a BOBO? Yeah, that's a BOBO. Okay, so that's going to be y is equal to 0 is your horizontal asymptote. What about this one? This one is going to be equal, so it's going to be 2 over 1. And this one is bigger on the top, so there's none. I'll let you look at that for a second. Let me go back. Okay. So when it's bigger on top, there is none. When it's bigger on the bottom, y is equal to 0. And then when they're the same, then it's just a ratio of a over b. All right. Find the domain and the asymptotes. So the domain, well, I'm going to have to find the asymptotes first. So I'm going to find the vertical asymptotes. And we're going to use the denominator to find the domain and the vertical asymptotes. Make that not equal to 0. Take the denominator. Make sure that I don't divide by 0. Solve that. Subtract the 9, or actually add the 4x squared to both sides. Divide by 4. Take the square root. And then that will be a plus or minus 3 over 2. You're going to have two vertical asymptotes. That means that the domain is going to be from negative infinity up to the first negative 3 over 2, the negative one, jumps over that one, goes to the positive 3 over 2, and then continues from the positive 3 over 2 to infinity. What about the horizontal asymptote? Well, what is this? It's bigger on the top, so there is no horizontal asymptote. What about this one here? We have this, so we look at the denominator to find the domain and the vertical asymptotes. Make the denominator not equal to 0. That means it's not 0 is not equal to x minus 2, or x can't be 2. Right? Took the cube root of both sides, x can't be 2. So there will be my vertical asymptote is x is equal to 2, but my domain is going to be everything but 2, from negative infinity to positive infinity, skipping over the 2. What about my horizontal asymptotes? It's bigger on the bottom, the exponent is bigger on the bottom, so it's y is equal to 0 is going to be my horizontal asymptote. One more. Here we go. This is going to be taking the denominator, making that not equal to 0. That means my domain is everything but the negative 1/2. So my vertical asymptote is going to be negative 1/2. And my domain is going to be negative infinity to negative 1/2. Skips over the negative 1/2, goes to positive infinity. And since these two are the same, the horizontal asymptote will be equal to negative 5 over negative 2. Alright, this one you have to factor. Make sure you factor the denominator. That means that the denominator can't equal 3 or negative 2. That's where my vertical asymptotes are. My domain is going to go from negative infinity to negative 2, skips over the negative 2, goes to 3, jumps over the 3 to positive infinity. And since the exponents are the same, then y is equal to 1, because that's where the coefficients are. Alright, okay, that's it. Do the Google form.